All right. Thank you very much for having me today. I'm really excited to be here. My name is Tyler Vanderplug. I'm the product line manager at JDSU for our line of fiber optic inspection and test equipment. And I'm really here today to be that guy who's shouting from the rooftops about the importance of the best practices for maintaining your fiber optic connections, particularly as it pertains to a practice that's been known about for several years. However, only in the past few years is it really gaining a lot of recognition and appreciation, and that has to do with maintaining the interface quality and cleanliness of your fiber connections. So a quick overview of our agenda today. I'm going to briefly give an overview of just inspection in general, what it's all about and the tools associated with that, then transition into fiber optic connectors. I know some of you are very, very closely familiar with what those are all about, and others may have more of a periphery 10,000 foot level understanding, and I'm hoping that I can clarify some of that with you with some of the things that are important to be aware of. And then I'll transition into talking about the biggest enemy or the biggest problem associated with troubleshooting today, associated with fiber optic contamination. I found a lot of humor in Matt and Tim's presentation in talking about even things like in the outside plant world that can contribute to contamination. This is the real world, and it's very practical. And just like fiber optics is as grandiose as it sounds, dirt can be your biggest enemy. And we'll transition into that, and then we'll talk about some solutions for how you can maintain some best practices to prevent that from being an issue. Here's just a quick overview of some of the tools that are oftentimes used when it comes to inspecting fiber connectors. You need a microscope. We're dealing with 125 microns or smaller, so you can't necessarily use your human eye to look at that. The one that's most common in a field environment are the probe scopes down at the bottom, as opposed to the ones you hold up to your eye or something that you use in a benchtop lab environment. More so something that allows you to inspect both sides, like a probe microscope. Just a quick overview as I refer to probe microscopes. It's a really versatile tool, just in that it can be used to inspect any kind of connector, whether it's located as a patch cord or located behind a bulkhead, and that could be ranging anywhere from a really simple single fiber SC connector or something to more complex connectors like an MTP multi-fiber ribbon connector, or something, an optical device located on a card or something. Just a quick overview of where inspection is done. I can wrap this up basically just by saying inspection is really done whenever fiber optic connectors are handled, and that breaks out into a wide assortment of different kinds of applications, as I show here. I'm going to transition into fiber optic connectors. Network managers love the whole idea of a connector, just because the reason they exist is to give you flexibility. It gives you the ability to have moves as and changes, as we all know. And so with that, we love that, but at the same time, you have to take the good with the bad, and because there's certain things that you need to know with them as it pertains to your attenuation and your loss, insertion loss, return loss, and such. It's important just to be mindful of how you can get the best performance out of your connectors. So why is inspection more important now than it was, say, 10 years ago? Well, obviously, hearing even like Tim and Matt talking, increasing higher bandwidth requirements is driving us to a situation where we can't just ignore this and think, oh yeah, that looks clean enough. It doesn't look black on the end of the ceramic ferrule. I think it's good enough. Fortunately, the service provider side of the industry has got about a 3 or 4 year jump in kind of discovering this. So a lot of the problems that they experienced in the past few years have paved the way for us to be able to have really good and efficient solutions for our data center applications. And one of the other things that I think is really important right now is we're at a really good opportunity with regards to technicians, because probably one of the newest things that you're seeing right now in the industry is actually new technicians. So you've got an opportunity right now to, number one, teach these technicians, get them off on the right foot. Even though they have limited experience, you can teach them now to do things right. And at the same time, sometimes the folks that are a little bit more experienced carry along a lot of kind of bad habits from several years past, and so there's a bit of a learning curve going on with a lot of these folks. Just because something worked for them 5 or 6 years ago one way, that might not necessarily be as applicable with the applications today. So real quick, I mean, this is anatomy of a connector. You've got, a connector body, which basically houses a ferrule. This is an SC connector. I pick it because it's probably the most commonly used, but there's all sorts of them, SC, LC, FC, MTP, so on and so forth. And then that actually is, the body itself is actually is a housing component for the ceramic ferrule, that white little stub at the end. And that's not to be confused. A lot of people will think that itself is the fiber, but the fiber is actually, the ferrule then houses the fiber in the very center of that. So typically with the naked eye, it's actually pretty tough to see. If you tilted at the right angle, you could see a little bit of that reflection of the glass at the very center of that. So even taking that down even a little bit further, for illustration purposes, I added a little graphic here at the bottom that actually shows a fiber protruding from the center of that ferrule. But in reality, that's not what it looks like. But I wanted to actually just show that for the illustration purposes to say this is the part that actually transmits the light is extremely small. There's no way that you could actually see any contamination really on that with the naked eye, unless the thing was covering the entire ferrule or something. And what we're talking about, looking for contamination the size of 3, 4, 5 micron, which is impossible to see with the naked eye. So I took a microscope shot here of actually what that fiber looks like through a microscope. All that white area around the edges is actually that white ceramic ferrule. And then the big gray circle is the fiber itself, the cladding, which is 125 microns. Now that said, the only part that actually transmits the light, as many of you guys know, is just the core of that right in the center, whether that's a single mode fiber, which is roughly 8 or 9 microns, or a multi-mode fiber, which is either 50 to 62.5 microns. Here is an example of a 50 micron, a single mode one, which is around 9 microns. So you can see here there's a couple of freckles and spots and stuff. Those are actually microscopic particles of contamination, and we'll get to that in a second. Just a quick overview of what you might see. As I just mentioned, here's the one on the left here is what a clean fiber connection looks like, with the white ceramic around the edge and the cladding there in the core in the center. The one on the right is actually a ribbon connector. Many of you guys, oftentimes in your data centers, might deal a bit with ribbon connectors as they're on certain devices, which actually contains a ribbon array of multiple fibers all on the same connector, ranging from anywhere from 6 to 12 all the way up to 72 or more now these days. Just really quick, focusing on the connection itself. Here's just a cross section of what you have going on in the connection. You've got the ferrule itself, and then the alignment sleeve in there that's holding the ferrule in place. That second connector comes in, and that's where they make physical contact so that the transmission can occur. And as I've mentioned before, the connectors themselves are widely known as the weakest and most problematic point in the network. Again, we have that love-hate relationship with them. They give us the flexibility, but at the same time, they're oftentimes the source for the biggest problems. So what actually makes a good connection? I break it down to, I call it the 3 Ps, just because it's easy to remember. You need perfect core alignment, you need to have that physical contact between the two, and you need a pristine connector interface. And these days, the first two, 5, 10 years ago in like the SCON days or whatnot, those other two you had to pay a little bit more attention to, and there were bigger factors. But now with zirconia ceramic alignment sleeves and apex offset machines and such, that just the manufacturers haven't been able to deal with the first two, so we as the users don't have to deal with that. So we're left with something that's built really well, but now it's our job to make sure that interface is clean. Even though they could even ship it to us in good condition, when it comes to us, simple touch of the fingertip can ruin that. And that's a perfect transition into talking about contamination itself. So it does require, contamination is the biggest source of troubleshooting in today's networks. A single particle mated between two end faces can cause significant back reflection, insertion loss, and damage, which I'll go into in a moment. And here's just a visual representation of what that looks like conceptually. So here's an interesting one. I referred to the back reflection and the loss that can be caused by dirt. Image one here is what you'll see on the chart here on the right is what's called an OTDR trace. Many of you guys are familiar with that. It shows the loss associated with an optical transmission over a period of over a distance. And every time there's a connection point, you'll see a little bit of a spike because there's a reflective activity. But then if everything is done right, you'll see that line just have that slow, gradual slope. You're not having too much loss associated with that. And the number one over there, that's actually an image that I show here on the top left. Number two looks like the same thing, so I figured it's not worth repeating an image that looks just like it. Number three, though, is this connector down at the bottom, which you see you go from significant loss going all the way. You actually get it's about 4.37 dB loss associated with that connector. Now, Matt and Tim were talking in their presentation about putting together loss budgets, which you guys are familiar with. Typical loss budget associated with a connector is usually 1.5 dB max. Sometimes people are a little bit more forgiving than that. So when you get a connection point that has 4.3 dB loss, you got a problem because you didn't budget for that. The interesting thing is with this one, you can see that connector is contaminated, but the only thing that's actually causing that loss, you can see in the very center, the core, that white spot there, there's a few little freckles on there. Those are actually the parts that are causing the loss. It's just that looks like two particles there. One is about 5 microns and the other is about 3 or 4 microns. It's amazing how something as microscopic as that can actually be your biggest enemy. So with that said, it's interesting. Although there's all that other contamination around there, a lot of times people will think, well, if the only part that I need to worry about is the core being clean, if I can have a filthy connector everywhere else and it should be fine. It's not fully thinking that through. And I wanted to give an example of that. Here's one of the biggest things that you'll see, a phenomena with fiber connectors, is that the particles will actually migrate over time. I oftentimes will like to use the example of like a water balloon or even a hand grenade. When that thing explodes, shrapnel goes everywhere. And here's an example of a connector that has a couple fairly large particles of debris associated with it out on the periphery. Now watch what happens after I've mated this one connector and then I inspect it again. You can see that debris just explodes and goes everywhere. Hey, the core is still clean. It's probably still be okay. But you notice after the third connection, all of a sudden now you've got contamination that moved in the core. The fourth one, now there's a big chunk that moved its way there. And the fifth one, it even gets worse. And so kind of all that to say is there's no rhyme or reason. It's not that it migrates to the core. It could go anywhere. And so associating that with loss, this is kind of an interesting trend as well. Watch how there's actually not even any contamination on the core with any of these, and then all of a sudden with this one you get that little particle on the core and you get significant loss. So another example of that, we're talking about the microscopic world, if you will, and so it's hard to kind of identify with that. So one example that I oftentimes give to people is this analogy here, where I'll take two glasses. You can do this at a bar or something, and take one glass and put a little pebble or something right on the top of it, and then slam the glasses together. And you look at the bottom of that glass, and you'll see there's all sorts of junk on the end of it afterwards. It's the same concept. It's nothing. It's just happening at a more smaller level. But it's something that people can identify with, and it's something that helps you understand the the impact of what those 2, 3, 4, 5 micron particles are actually having to a larger scale. One thing that's interesting to point out, with this example, people oftentimes, it becomes a little bit more clear to them that oftentimes when people are inspecting fiber connectors, they oftentimes won't inspect until after they're getting their OTDR trace, and they say, oh, geez, I've got 5 dB of loss going on with here. Let me take a look at that. Oh, sure enough, I've got a dirty connector. Problem with that is that's too little too late. You already mated those connectors together, and you've most likely embedded a lot of those particles inside of the glass, which is going to create pits. And even if you are able to remove them, now you've got chips that are in the way, and that's permanent damage to your connectors. And also you're causing back reflection that's sending it back to your sources. So just understanding it from a data center perspective, the exponential impacts associated with this, if you've got one connector that has contamination just at the very beginning of your network or in your data center, that really it could trickle down everywhere. Let's say that thing was branching off to 4 or 5 locations. You could have taken a lot of things out with just one connector that happened to have a 3 micron particle in the core. So just quickly looking at the sources of contamination, it's fairly practical. You got dirt, oil, pits and chips, scratches, things like that. The biggest enemy is probably dirt. Oil is something that kind of attracts a lot of dirt to it, or if there's anything nearby, it'll stick to it and stay there. But all of these can actually, or the dirt and oil can actually be easily removed if you're dealing with it proactively. The problem is that dirt is everywhere. It's on your hands. It's in the air, especially when you go out to outside plant locations. You're dealing with all sorts of exposure to dust and debris everywhere. But it's something that we just have to. It's there. We have to deal with it. We're not going to be able to remove, even from our data center, all the dust particles that are 5 microns or smaller. And even though that's our biggest enemy with fiber connectors, and even a brand new connector can be contaminated. A lot of people say, "Well, I just put the manufacturer builds these things, they ensure it's clean, then they put a dust cap on it and they ship it over to me." Even that, the dust cap can be a source of contamination. Even more so, the dust cap can actually develop condensation in it. I recently was meeting with some contractors on the East Coast, and they had a whole slew of these pre-polished fiber optic connectors that they don't have to, that means that they don't have to terminate them. I mean, they don't have to polish the end faces and things. And the mentality is that when you have to manually polish the end faces, part of the practice is to inspect it and make sure you don't have any chips or anything. So it's a step that's kind of built into their installation procedure. But these connectors that they were using were pre-polished, so they figured, well, I don't need to look at the end face. The factory sent it to me, and I have to assume it's good. And so I looked at every single one of them, and every single one of them actually had developed a mold compound inside of there just because of the oils and the condensation, just inside the dust cap alone. Now, fortunately, that can be easily removed. You inspect that, you look at that, and cleaning processes will take that right off because you haven't embedded it in yet. So just kind of quick zooming in. You can't see that by even looking really close at that, but zooming in when you actually use a microscope, I circled a few particles here that are 2, 3, 4 microns that you could never see without actually using a microscope. Another thing to keep in mind is with dirt is that I mentioned dust caps and things like that. People can be the source of those with your fingertips or just daily handling. Another big problem that people often have is their own test leads in their test equipment. You've got Joe technician who always carries he's got that one test lead that he carries in his bag with him. However, if that one becomes contaminated, you run the risk of every single connector that you plug that thing into could either damage the gear that your equipment that you're testing in your network, or vice versa. You could be damaging the connection inside your test device itself. And we've seen both of those happen. They've been very costly mistakes by folks in the service provider side that have kind of taught us ahead of time so that you guys don't have to deal with that. Fortunately, the solution with this is fairly simple. I joke that this is the world's most simple process flow diagram. And fortunately, it should be that way. You inspect the fiber and you ask that question, is it clean? Yes or no. If it's not, you clean it. But here's the step that most people miss. After you clean it, you re-inspect it again. How do you know it's clean? A lot of times, these people's cleaning process could be, rubbing the connector on your shirt. Technically, that could qualify as cleaning, but you might want to just check that and make sure that that works. There's other methods that you should look into that are probably a little bit more effective. Is it clean? Yes. All right, now you're good to go. You can connect that. And this is a really easy best practice to have. I kind of put showing the tools of what this looks like. Same kind of thing. Inspect. Here's an example of a probe microscope inspecting the connector located behind the bulkhead. If that's dirty, you clean it. It shows a little tool that's being used to clean it. Re-inspect it again. Okay, you're good to go. Now you can connect it. Now, a couple things to keep in mind with fiber inspection associated with that practice. Make sure you inspect both sides of the connector. This is probably the biggest oversight. You ask a lot of folks, well, I inspect my connectors. Sure, every patch cord I have, I always check it and make sure it's good before I plug it in. Well, that's only half the connection, and more than half the time the problem is actually on the other end. So without inspecting both sides, you actually are kind of wasting your time. And so using a microscope, like a probe microscope that has various tips and things, you just change the tip out. One side is for a patch cord, then you switch that tip over and it allows you to inspect inside the bulkhead. And you can see here there's a little video display that you can hold in your hand that allows you to look at that, look at the end faces really easily. Here's another big one, proactive. Make sure that you're inspecting proactively. I touched on this a little bit earlier. Here's an example of you inspect a connector, you see a little bit of dirt on it, so you clean it, and it looks fine. Now you're able to connect. Contrast that with reactive inspection. This is that one where you saw some loss on a connector, and so then you go to inspect it. I mentioned before not being able to remove that stuff once it's embedded. Here's an example of I took a connector, I inspected it, and it showed some contamination on it. And then what I did was before cleaning it, I actually mated it, and then I cleaned it, and then I re-inspected it. And you can see here there's a lot of those little black dots and stuff. Those actually got embedded into the fiber itself, so they couldn't be removed. So a simple best practice of making sure that you're doing this proactively. This is a huge mistake that people make just because it's the mentality of thinking of inspection as a troubleshooting tool as opposed to a best practice. Like whenever I was just recently, my wife had a baby and we were in the hospital, and everywhere I looked in this room were little signs by the sink or wherever that said, before you do anything, wash your hands. Wash your hands. And there's germs all over in the world. And I thought that's actually it's kind of the same concept here. We've got it in our head that whenever we cook food, whenever we do anything, we wash our hands. It's the same thing whenever you're handling fiber. You should make sure that you inspect that, clean that, and just double check that to make you actually have the ability to see if the germs are there or not. To extend that analogy. And again, some of those benefits that you're going to get out of this are reducing your network downtime, reducing troubleshooting, optimizing your signal performance, and of course preventing costly network damage from occurring. And so it's a really simple habit that you can make that really yields a big benefit. Now, I liken this example to exercise or something. Now, we all realize that we need to exercise better and we should be going to the gym. This is something that we all nod our head and say, yes, I should be exercising 3-4 times a week. But we all also make excuses why we don't do it either. It doesn't fit into my schedule or whatever it may be. I'm too busy. It's the same thing with something like this. We can all nod our heads and go, yeah, I need to be inspecting fiber. That's what you got to do. But then when it actually comes time, you're in a crunch situation. You feel like you need to cut corners. Oh, I don't need to worry about that. Fortunately, this is why I'd say make sure when you're picking tools that actually let you inspect, choose the right tools that actually are built intelligently, rather than maybe even using a simple microscope. There's some products actually on the market now that will actually combine inspection with other tools that you use. Like everyone has a power meter, for example. This is an example of a product that has a power meter with the inspection portion built right in. So it folds it into your regular workflow. You're already taking a power measurement, And your inspection microscope is right there, so you don't have to deal with setting down other tools and other kind of stuff. It folds into your workflow better, and particularly as network managers, we like this because you know that you can give this tool to your technician, and if everything is right in front of them, and here, this one here is actually in a little hands-free device that hangs around your neck, they're more likely to use it if it's right in front of you and it's designed with a good workflow in mind. So where does inspection occur? This is kind of basically just saying every stage that fiber is handled, and this could start everywhere from the component manufacturers all the way through to the troubleshooting and maintenance side of things. And this is slowly working its way through right now, where we're every single one of these little boxes. This is happening now, and people are paying attention to it and actually doing it. So just wrapping things up, connectors are valuable and essentials, but they need to be handled properly. It is the #1 source of troubleshooting in today's optical networks. And fortunately, the challenges can be easily overcome with proactive inspection and cleaning. And visual inspection of the fiber connectors, really, you have to have a microscope in order to do it. You can't use your naked eye to look at that. It's not going to get you very far. And a probe microscope, I'd recommend that's probably the best way to go. It's a really effective tool. It allows you to see both sides. You can see it on a screen, so you can show it to other people around you, and everyone can say, "Yep, that's a problem. Let's deal with that." And then proactive inspection, fortunately, is easy, and there's lots of benefits. You get reduce network downtime, prevent troubleshooting, optimize your signal performance, and prevent network damage. So kind of the slogan that I like to use is always inspect before you connect. And with that, I wish you guys the best, and hopefully this is something that sticks with you guys throughout your practices. All right, thanks a lot.